Welcome to Pondering AI. I'm your host, Kimberly Nevela. In this episode, I'm so pleased to bring you Dietmar Offenhuber. Dietmar is the Department Chair of Art and Design at Northeastern University. In addition to his professorial duties, he researches the material and sensory aspects, as well as the social implications of environmental information and evidence construction. For purposes of this conversation, construction may be the operative word, as he joins us to discuss both the philosophical and the practical ramifications of synthetic data. Welcome to the show, Dietmar.
Thanks, Kimberly, for the invitation. It's great to be here.
Absolutely. Now, your educational background is interesting because it spans from architecture to a master's in media arts and science and a PhD in urban studies and planning. And I think the link between architecture and urban studies and planning is probably somewhat intuitive to most of us, maybe not so much media arts and sciences. So tell us a little bit about what inspired your path and has ultimately led to your current interest in how we understand and use data today.
So I would say everything that I did was always, I was always interested in cities as, kind of human entity, places where, social interactions happen, where a lot of activity, a lot of change, a lot of, intersections with technology and so on. So my interest as an architecture student was always mostly on the urban level, but I actually, like in the middle of my architecture studies, I dropped out of school in order to join Ars Electronica, which is a media art organization that had a research lab, and this was like a very interesting opportunity to do this. I later returned and finished my studies. But so this connection between data, cities, and visual representations or perception of cities, that was something. Was a place that I started from. Media Arts and Sciences, that is the media lab at MIT, where I joined a group, Judith Donath, social media, as it was called back then. So she was really interested also in connections between mediated spaces and physical space. And my PhD then was in urban planning, so I would say compared to architecture, much more of a social science perspective. But again, focusing more or less on similar topics, dealing with, urban data and how does it correspond with urban activity, with what people are doing, what people are experiencing, and so on. So in a way, that kind of connection with data, representation, visualization, and cities was always the connecting element.
Yeah, that as you've been talking about, that just makes good sense, that connection between the information and the data we have, and how does that actually relate to the activity and the engagement in reality, so to speak. You recently wrote a paper on the topic of synthetic data and how synthetic data may challenge us or require us to shift some of our traditional perspectives on data, or how we conceptualize data and understand data. And before we talk about that shift, it would probably be important for us to define what we mean by synthetic data for purposes of this conversation. So when you think about synthetic data and talk about synthetic data, what is it that you're describing?
Mm-hmm. So I mean, I think in the context of this conversation, we're probably mostly going to focus on data that is generated by AI models to somehow resemble observations, like traditional data that mimic data. But of course, if we think about synthetic data, it's of course a much broader topic, data that is artificially generated, not derived from observations of the world, generated by algorithms, by all kinds of operations, is of course a very old topic. I mean, we if you look at what the network scientists are doing, in the 1950s, 1960s, they generated random networks to study them. Those were already a form of synthetic data. Or in statistics, you have a lot of statistical methods that require you to have a complete data set, not having any gaps in it, because certain operations don't work otherwise. So what do you fill it with? Do you put in some zeros that might create a artifact or a bias? So this data imputation is also a very old topic, how to augment a data set. And then, of course, you have all kinds of other there is synthetic aspects creep into data sets in all kinds of different ways, and I'm sure you have had a lot of that on your show. But it starts if you're talking about urban phenomena where you deal with census data, the boundaries of the census tracts shift, so somehow the data sets are not really compatible. So you have to involve some form of synthesis to harmonize them, to make them comparable. So, and that can be very, very small interventions, or it can be very big interventions. So I kind of, in this paper, I made a small typology that covers some of these synthetic aspects.
And without going into necessarily all the typologies that you identified, because one of the things that jumped out, and again, I think it's obvious when you think about it in retrospect, it was that synthetic data really does exist on a spectrum. There's maybe those two discrete endpoints and then some waypoints in between. So as you think about it, what are maybe those endpoints, and why is it important, or is it important for folks to differentiate where they are on that spectrum when we're thinking about how and where to apply different synthetic data techniques?
Yeah, I guess there are different dimensions of it. One of it is really why do we synthesize data? And I think right now the two main common reasons are first to protect privacy through differential privacy. And there the synthetic methods are a little bit more gentle because it's more kind of recombining, just making sure that individuals are not disclosed, or that their identities are not disclosed in a data set, which is actually quite difficult, but that's a different topic. To this other end of the spectrum, where we're really looking at synthetic training data that are not only just, let's say, augmentations of data sets that we don't have, but sometimes they can be complete improbable outliers that are meant to really make the models a little bit more robust. Or we have data sets that represent different outcomes of the same situation. We only have one world and there's only one wave. There's no counterfactual scenario, but synthetic data allows us to generate counterfactual scenarios to train models in these different possibilities.
One of the things that the paper proposes is that when we are thinking about and applying synthetic data, we might need a different conception or a way to understand it. And I'd like to talk about the difference in those models and why that might make sense. And perhaps just starting with what our traditional conception of data has been, which you called the representational model. So what is the representational model of data that we've all been known and loved historically?
Yeah, so data are or is a form of representation. This is how most people would understand it, in a sense that data sets consist of symbols that reference things that exist in the world. So for example, like location data point references a place in the world, and the idea of what I call the representational model is that the only thing that matters, or the meaning of data is in this reference, is in the data value. So it doesn't matter if the data set is etched in stone or sung from a mountaintop or found on the internet. It is just the data value and what it represents in the world that matters, which of course is very convenient, because then we can kind of combine data from many different sources, and we know, of course, that it's a reduction, it's a simplification, but that is very often a good trade-off to make. But of course, there's also a disadvantage with this, because if we completely ignore where data come from, the different origins come with different biases, come with different issues, and so on. If you, again, take the example of geolocation data, it might be acquired from a GPS device. It might be, geocoded from an address. It might be acquired by just throwing a dot on a map. So all these methods come with different errors and biases. But if I only focus on the data content, I don't see that.
And there is an implicit assumption in this model as well, right? And that is that the data directly has some sort of, maybe it's not one-to-one, but one-to-something relationship to an actual real-world concept or construct or thing. Dr. Erica Thompson, talks about this a little bit, and she very much cautions us that the data we collect and the models we erect are just, as you said, representations, not replications of the actual physical object or phenomenon that we are trying to model, although it is very easy for us to lose sight of that, I think, sometimes. What was the old byway that all models lie, but some are useful? You also note that even in this traditional view of data, there are some shortcomings, and I think it's a related, although slightly different point, which the paper points out that sometimes data is just a byproduct. It's not really an encapsulation truly of the real world concept or construct. And why is that? Why was that important for you to point out and for us to understand?
Yeah, of course. No, this is a very good point, because, of course, even on the most basic level, not all data forms not all data that we work with is a representation of something in the world. Sometimes it's really just a byproduct of some algorithm or something. So you could think about it as second-order representations, but then it's not super useful. But often they are just artifacts or objects that are used in some form of operation. But I think before we go into this alternative ways to conceptualize data, you mentioned also other disadvantages of this representational model. And I think one important one that I want to come back to is that if we think of data as references to things in the world is, of course, also not static. The world is constantly changing, constantly evolving, also in response to the way how we use data or how data is operationalized in the world. So that is also not really considered here. And I think, of course, representation has always been a very fraught concept, but it's also useful in some ways because it allows us to do science. It allows us to use deliberate assumptions, to use deliberate reductions, to use data in a way that transcends their original purpose. So we can now look at a data set of night lights on Earth from space and use that as a proxy for economic activity. So all of that somehow depends on a certain understanding of representation. But representation is not the only way. We can look at data, and so I'm not saying one thing is wrong and the other is right, but those are kind of different lenses, and representation or media in general have that effect that they create their own reality. Like once I have a data set, the data set creates its own reality, and then I start looking at the world through the lens of that data set. So for that reason alone, I think it's important to look at alternative conceptualizations, how to think about data.
Well, and it is interesting because even in that very simple example of looking down and trying to use, lamps and lighting as a measure of economic activity or progress, again, at a point in time, if we're looking at data, something is I would say, static and mutable versus sort of fluid and representing a point in time and not representing an absolute reality, because certainly there's other reasons why you might not have, a lot of lighting in an area that still is economically prospering or developing. So it's one minute. So that's one aspect of it, which is, there's not all interpretations are the same, but to that point, which is it's a point in time and it doesn't necessarily represent. And maybe this is particularly true when we're talking about people-related data, the fluidity and the potential of reality and how it can change.
Yeah, absolutely. So I think one alternative way to think about it, and I think we all know this from our daily experience, that meaning is not necessarily explicitly in the words that we are saying, but very often it is in the way how we say it. So meaning is in which situations we say it. And so meaning is very often in the context. And what I describe as a relational concept of data basically means that it is that meaning is contextual. It depends on how people use a data set to make an argument in a concrete situation, let's say in a courtroom. It's about its materiality, how that impacts its use. So this would be an alternative aspect that is deliberately stripped away from the representational model to simplify things, but we can still take all kinds of data sets and look at them through a relational lens.
And so do I understand you correctly there that with a relational lens, we are not assuming or maybe presuming or projecting that the information that we have in front of us is in fact a replication or a duplication or a direct representative of a concept or a construct, but it's specific to a usage and a context of the information, of both based on when and where it was collected or how it was generated and for what purpose it was generated. So is this idea of value, performance, and context more intrinsically linked to our understanding of what we're trying to do with the data than it might otherwise be in that kind of representational model where we assume that the representational is just, again, it's a digital duplicate of something real?
Yeah, exactly. I mean, focusing on representation often makes us overlook all these other aspects that contribute to what we consider meaningful or not. And this kind of more relational approach to data that really looks at the way how people use it, how people share it among themselves. Is it something very ephemeral? Is it something that is very immutable? What kind of settings does that data? Yanni Lukisas, a critical data studies academic, talks about data settings instead of data sets. So, all these things are, of course, important in the way how we use data in the real world. And if we reduce it just to the kind of content of the data, then we just ignore all of that.
And why is this model, the relational model in particular, do you think more productive? I don't know if productive is the right word. You can tell me the right adjective there, but a better lens through which to think about and view synthetic data in particular?
Yeah, I mean, it's interesting because like all these criticisms also apply to any data set that we're using, but synthetic data makes it particularly clear. First of all, because representation goes out of the window right from the beginning, because this particular kind of synthetic data sets that we talked about that mimic real data, they don't have a they don't have a referent in the world. They are just mimic how other observations, they're simulated observations of the world, but they don't have a direct referent. So there is no representation. So that's the first thing. But then I go a little bit more in detail in the way how we think about data quality in relation to synthetic data, which completely puts or inverts our understanding of data, as I argue. So, for example, if we consider the data quality of, let's say, census data set or something that represents a population, we of course want to know how well is that population represented in the data set. So we have that, of course, goes back to the question like how did people knock on doors and ask people for their information, so this kind of evidentiary chain of custody that points back to the phenomenon is really the one thing that is very important. Now, if you look at synthetic data, it's exactly the other way around. How useful a data set is not necessarily a question of how well it represents particular people in the world, because there is no connection, it just mimics the kind of observations. But let's say, how successful is a AI model that has been trained with this particular synthetic data set in recognizing things in the world. And if we consider these different use cases of synthetic data, whether it's for privacy protection, whether it's for training or conducting statistical analysis, we find that a certain degree of artificiality of a synthetic data set is appropriate for one use case, but maybe not for another. So in a way, it's no longer about how well a synthetic data set represents the world, but what a model that has been trained with it is able to do. And that's like a very, very different way to think about data, very more relational.
Yeah, I was going to say it's a quiet, but really fairly profound point as you're thinking about that. Does that also mean that when we're using fully synthesized or generated data, that our conception of a ground truth also shifts? And if so, why or how?
Yeah, I mean, ground truth is, of course, a very interesting topic in machine learning, and I'm working with Beth Coleman from University of Toronto on a paper along those lines. But in machine learning, of course, ground truth, well, let's say in the traditional sense, in geography, ground truth means that, okay, we have a satellite image, we analyze the satellite image and try to figure out what's going on. So in order to figure out whether that is really the correct inference, someone has to go there and see if the situation is actually the way how we read it in the satellite scene. So that would be the ground truth, that you actually go to a place and you actually figure out what is going on there, which of course is also like in a military context a very important idea. But in machine learning, it refers to the training data set. So the training data set is the ground truth. The training data set could be entirely artificial, generated by a 3D game engine to create an artificial city that is used to train a vision system for an autonomous vehicle. But that's the ground truth we're talking about here. Again, this kind of representational quality is, I'm not saying it's not important. Yeah, obviously, it is important. What kind of reality gap we are talking about, but everything is a little bit more complicated.
Mm-hmm. And so you made mention a little bit earlier here about the idea of counterfactuals and our ability to generate data and synthesize data to play through different scenarios that don't necessarily have to relate explicitly to something that's happening, quote unquote, on the ground or in reality. So it would seem to me that there's a liberating factor in our ability to do that, as long as we don't lose sight of the fact that this is or should be thought of as a counterfactual, not as sort of real world evidence. Do I have that correct? And how should we think about that with synthetic data?
I mean, there's an interesting aspect. First of all, data is not just for analysis. We do a lot of things with data, and data analysis is just one of it. But very often, data is also some kind of speculative artifact for thinking through a scenario. And this is, of course, what is important in training of models, where you are not just trying to train it on the most common cases, but also on extreme outliers that are not really encountered on a day-by-day basis. But in a way, since I'm coming more from a social science, so this idea of data being more than just bureaucratic evidence to support decisions that I may have made already in the first place, and I'm just looking for data to kind of justify that. But as something, imagining, okay, I have some kind of agent that throws speculative scenarios at me, always with synthetic data sets, and my decisions change that, and then you have a kind of a different counterfactual world that is constantly evolving. So in that sense, I think we can also, as long as we understand what we are doing, use this kind of speculative quality or capacity of hallucinations or synthetic data artifacts.
But when does that get dangerous? So is it when we lose sight of the fact that these are, in fact, again, back to that, how they relate to, that this is really a relational representation, and we start to believe that this is, in fact, I think representative of reality? Or is it also just an understanding of how do we interpret the model, the outputs of a model differently when we're...
It's inherently very dangerous, because data sets don't always come with a label of how exactly they were generated, where they come from. And in the sciences, that is maybe a little bit less of a problem than, let's say, in all those different professions where people are professional data analysts who, just don't really go into the metadata all that much. And so for me, also in my other research, this question of data origin, what are the processes, what are the social processes that lead to a data set, is again where the interesting stuff is happening. This danger of data pollution with synthetic data, biases that basically self-replicate and get worse and worse. All of those are considerations, but it's already implied in the way how we, so I would say it's not limited to synthetic data, but synthetic data makes everything more obvious as a problem.
Mm-hmm. And you mentioned your work and interesting from the social sciences perspective. One of the things that we hear often with synthetic data is this is great because it allows us to expand the patterns in the data. And I'm interested in your thoughts about, does this only allow us to expand or create a bigger volume of data for things that we already know? Or does synthetic really help us capture, what someone sometimes refers to, all possible patterns.
I mean, again, it really cuts both ways, and it's a fascinating question. So on the one hand, just doing real, data analysis from real-world data sets, they are usually very messy, and sometimes those errors or mistakes that they contain are the actual evidence that I'm looking for. So nobody can just say, okay, let's disregard this is an outlier, it doesn't matter. It may be the only thing that matters. So these kind of frictions and contradictions that we sometimes find in data sets that usually have their source in a particular way, how the data were generated, are important, are meaningful, and we can kind of look at them in different ways. We can look at them as biases that need to be corrected. We can look at them as errors or other kind of anomalies that we have to exclude. But we have to look at them from all kinds of different perspectives. And with synthetic data, there's a little bit this danger that we stop doing that. If I look at data from a material perspective, noise always has some interesting meaning in it. Sometimes it's the noise that tells us what we want to know. So I can give you an example. If we think about, New York has this data set of GPS data from all taxi rides. And you see this extremely blurry in Midtown and in downtown. And this is, of course, because the tall buildings and the narrow streets interfere with the GPS signal. But suddenly, when I just look at the two-dimensional geodata that I have, suddenly I can kind of extract the three-dimensional shape of the city from the noise, from the error. So it's not always clear what can be discarded in a data set. And we can't really say what are the relevant features in a data set. So with synthetic data, there's a danger of really, making it too good to be true.
Mm-hmm. Mm-hmm. That representational idea, I suppose, relates in some ways to the idea of bias and the very real fact that in a lot of cases there are populations or profiles or scenarios that aren't represented in our digital data for a number of reasons. And so synthetic data has come around as well. Another of the significant value propositions is that we can use it to debias our data. You take pose a bit of a provocative question or provocation relative to this. Is synthetic data an effective way to debias or get rid of bias in data sets?
I mean, you can maybe correct one particular aspect of it, but that doesn't mean that the whole data set becomes more representative. But this is what a lot of people are working on. They say, okay, the data set has known bias. Like, we can deal with known biases, but I mean, we were always able to, if we know a bias, we can do something about it. But the problem is always the biases that we don't know anything about. And of course, bias also implies that there's a certain gold standard or some truth or some true representation. We say, okay, I have a population to compare my data set to. How does it match? How does it fit? So I can quantify the bias here. But if we talk about cultural phenomena, like, what is it becomes a little bit more harder to conceptualize biases that represent a certain perspective of thinking versus another one. So we can't really quantify that in the same way. But let's say we stay focused on this kind of quantitative idea of bias that we want to correct for. I mean, there are a lot of researchers in synthetic data who propose methods of debiasing by just adding missing observations into the training data set, and often in surprisingly crude ways. So it's very brute. It's a very brute force approach. If all what you want to do is to shift the mean a couple of percentage points, then that's possible. What I'm wondering is like, is that a viable strategy to at scale to think about aspects of a population that we are not aware of?
And so if we back up a little bit and take a wider view, why is it important for you in your work to really take the time to research and think critically about both the nature of synthetic data and where and how it's being applied today?
Yeah, I mean, a couple of years ago, I got really interested in data materiality. I wrote this book, Autographic Design, which is about ways to visualize the material origin of data, to work with physical traces. This interest was triggered by my observation that a lot of activists in environmental activism, social justice, or people who look at misinformation from a forensic side, are increasingly using very material or physical displays to make a case for evidence. And that happened after 10 years of data literacy and visualization literacy. So like, okay, if visualization and data analysis is so superior, why do they go back to these very analog ways of showing information? So I was interested in these kind of methods of showing the data origin as a part of the larger discourse around how do we think about a particular phenomenon. But what struck me was that these kind of very non-representational approaches that are central to these methods are also visible generally in the field of AI, where we often don't have an ability to really trace data or outputs from a model back to a thing in the world, to a representation. So we somehow have to deal with this data generation process that is somewhat opaque, but we can kind of probe it, we can experiment with it, we can do certain things. So this is where I think synthetic data is interestingly somewhat similar to these kind of trace phenomena in the world that just pick up a lot of fingerprints as they move from hand to hand.
Interesting. Now, you said one of the questions you were thinking about there is, why were we reverting to more analog? For some reason now I'm just over-indexing on the word representation myself in my questions, but to more analog ways of thinking about or visualizing information. And I have to ask, why were we?
Why? Well, it's interesting because if you look at the big controversies, let's say climate change or pollution, it's not really the interpretation of a visualization that is put into question. It's always the data source. So that people don't say, well, this visualization is great, but you can also look at it that way. They immediately jump to this point where they say, well, how do we know that the data you're working with is even valid? And this happened, when the famous hockey stick chart became, circulated in the media. The first challenge to it was, there's this tree ring data set that is just way too sparse, and we cannot really draw any conclusions from these few tree rings. So it has immediately a debate about the data source. The problem with visualization and data analysis is that they can't really help us to make these arguments, because visualization can only start once we have data. And the data origin, as we know, gets easily forgotten because data generate their own reality. So the question of how to make data collection more accountable, especially when the data set is collected by activists or amateurs who don't have the institutional credentials, they have to try very hard to show that the way how they collected the data, is compelling. In other words, they need to very tightly connect the phenomenon that they care about, to the data that they generate. And this is where you really get into these very material dimensions.
Yeah, and you can see as we move into the world, because you said it's the data they generate, and in that case, the data they're generating may have very well been data they were collecting and inputting based on observation or physical discussions or surveys or what it is. But today, the data we're collecting may represent what we have generated based on an idea that we had. And so answering that question about why should I believe that the information that you're giving me is valid based on the assumptions you used in generating it, gets really, really interesting and really sticky. Does this then change how we have to think about data literacy, thinking about sort of model literacy, if you will, and how we teach and understand data and information?
I think so. I think so. And data literacy is an interesting word. I have some problems with it, but I also use it because it is important. But literacy implies that someone taught you in elementary school how to read a book. But this is not necessarily how we interpret visualizations and images, even if we don't have the canonical way of decoding it, we might see some meaning in it, and we might construct meaning together with other people. I mean, this is what the whole critical cartography movement in the 90s made the case that the way how we read maps is not that we don't study the legend in detail and then see, oh, what does this symbol mean? But we are at the subway platform together with other people, trying to ask them, how do I get there based on this map? And then people just construct meaning from whatever is at their disposal in this particular situation. And the legends on the map are rarely ever really consistent, unless you're, let's say, a sailor and work with the NOAA charts that are very consistent and very precise. But there, the legend is a book that has 100 pages. So, the maps, the charts are very reduced. So I think this data literacy is in a way, taking the responsibility from the designer and puts it on the audience. So you say, okay, you are supposed to learn how to read in school. It's not the responsibility of the author if you can't read the book because you're supposed to be able to read. That argument doesn't fly in visualization. The responsibility of the author is much bigger, I think. Because they have to somehow anticipate that construction of meaning in a certain situation.
And you had made the comment earlier about sort of the traditional, I'll call it a problem, charitably, that, folks, even in traditional analytics, right, data analytics, where you have a decision you have made and then you go to find the data that supports it. And it seems to me that if we want to be in a position, particularly in an era where a lot of the data is being synthesized, so therefore it is projecting something, it is a projection, right, of a belief about the world or the state of things in relation to some objective and outcome, we really do have to take more onus to explain why we think that is an appropriate projection, an appropriate, maybe even counterfactual. Otherwise, we really do open the doors to this sort of continuing problem we have now, which is it's so easy for folks now to go out and generate their own view of the world. I think you might have referred to it somewhere as the malleability and the ease today of even generative AI systems makes it so easy for everyone to fabricate their own. I think you called it an Instagram reality of data, and it just puts additional pressure on this point, doesn't it?
Yeah, I mean, that's for me a really scary, scary aspect of this whole story. Where, you can no longer distinguish, like which parts of the data set are observations, which parts are assumptions, which parts are, and even observations contain obviously all these assumptions, as we all know. But like things get much more complicated with synthetic data, and it has something to do with this way how we also scaffold meaning. Like there's no real ground truth where we kind of dig down and say, okay, this is where we can anchor everything. We can just compare and contrast things, and contrasting things is the way how we learn, I would say. But it becomes incredibly difficult if you have media bubbles where these contrasts that are prepared for these situations where you have scaffolds that support viewpoints in many different directions.
So I want to take just a slight turn because in the interest of non-representational computing systems, I feel like it would be remiss if I didn't ask about your water-computer collaboration with Orkan Telhan.
So I mean, again, this came out of this interest in non-representational ideas of data, which on the one hand started with this data materiality that went into the non-representational aspects of digital data, but also took me back to a lot of analog computational approaches. You could say, if you take a wind tunnel is a computer to calculate turbulence. Problem is, it doesn't give you a number. It instantaneously gives you a picture of that turbulence, but you have to measure it somehow, which is the problem with analog computers. But the idea of having AI systems and having computational approaches that don't require silicon and digital artifacts and digital representations was something compelling. And there's a whole field in computer science and physics that is called physical reservoir computing. So they look at physical phenomena. It can be anything from water ripples to vibrations or light impulses, light reflections, to replace some parts of deep learning models. And just by kind of using the partly chaotic, partly deterministic qualities of these phenomena to transform data in a way that makes it easier to be picked up by more simple neural networks that don't need as much energy to train. And this notion of using physical media to calculate. As an urbanist originally, I was interested, like, how can we think of a city as a computer? And so we currently have a water computer in the Venice Biennial of Architecture, where that predicts the time of day in Venice based on how disturbed the water surfaces in the canals are, and it uses water to calculate that. So I think a lot of people are recently interested in these kind of non-conventional computing approaches, because everyone, of course, knows the immense energy consumption that machine learning AI needs, and they also understand that not everything needs the numerical accuracy and determinism in order to get something useful. So a lot of people are looking at kind of bringing in these kind of analog aspects into into machine learning.
That is absolutely fascinating. I think in an age of all things digital and going digital faster and more digital, that we are hearkening back to more analog perspectives. And I had never heard of this particular area of computation and physics. So we'll provide the link to that in the show notes. So as we're wrapping up here, and you've been looking at and thinking critically about synthetic data, what do you think are some of the most important open questions or things we should be aware of as we move forward in this world where synthetic data generated information becomes more and more prevalent?
I mean, there's no single point I can highlight, because all of these are just, all of these aspects that we discussed are super meaningful in one particular aspect. But for me, it really comes down to widening our understanding of data a little bit more, that data is not always a digital file. It can be a physical artifact. It can be a physical trace. Data is not always, a data set is not always something to be analyzed through statistical means. It can be something that plays a role in the way how people debate a certain issue in all kinds of other ways. Data can be provocation, data can be a prompt, data can be a counterfactual scenario. So thinking about data a little bit outside of these very narrow confines, I think is one way how we can talk about all of these scary aspects and dangers, maybe a little bit more nuanced.
I love that. And I think that's a great note to leave with all of us who are buried in analytics and AI and data this and that up to our armpits, as you will. So thank you so much, Dietmar. Goodness. Thank you so much, Dietmar. I really appreciated your time and the insights today.
Thank you, Kimberly. It was great. Thank you very much.
To continue learning from thinkers, doers, and advocates such as Dietmar, you can find us wherever you listen to your podcasts and also on YouTube. In addition, we want to hear from you. So if you have comments, questions, or guest suggestions, please write to us at ponderingai@sas.com. That's ponderingai@sas.com.